A new day, a new problem to solve. Today's problem is of a level medium and it's called the longest palindromic substring. So we have a function that's called the longest palindrome that takes as a string s as an input, and the goal is to find the longest substring that is a palindrome. So what is the definition of a palindrome first? It's basically a string that is symmetrical. For instance, BAB is symmetrical because A is in the middle and anything on the right side is symmetrical to the left side. Another one also, ABA is also symmetrical, so it's a solution. And the goal is to find the longest one. As you can see in this example, BABAD, any letter, for example, B, is actually a solution of length 1. However, the goal is not to find any solution, is to find the longest solution. For this second example, CBB and D, BB, this is a symmetrical substring, which is a palindromic substring. And this is the longest one of length 2, so this is gonna be the solution. So I'm gonna try to draw a little bit some examples in order to understand how we're gonna solve the problem. So first we're gonna have an array. We're gonna have an array B, C, D, and we're gonna the goal is basically to iterate element by element in the array by an index A, and for every element, like here for example, we're gonna check is this is a center of a palindrome. So I'm gonna check on the right and on the left till I find the longest based on this center. And then once I'm finished with that center, I'm just gonna keep moving to the next one. So I'm gonna be centered here, and then again I'm gonna check. And the moment I find the biggest one, I'm gonna update my solution, and they keep moving forward. So fairly simple so far. And let's see how we're gonna find a palindrome in some cases. Sorry, it's a palindromic string. So let's just say I'm at the index I. So I'm centered here, and then gonna have BB, D, and another D. And then here I'm gonna break the example by having something different. So in this example, I'm centered as I said here. I'm gonna change the color so we can have better representation. So I'm centered here on A, and I'm gonna have 2 pointers. One is here and one is here. And I'm gonna compare them. The moment I find that they are equal, I consider that they are a solution. So first when I started here, this was a solution of length 1. So I take it and I compare it to the longest solution that we have. And if it's bigger, then we take it. And then because we compare these two and we find that they are equal, so this is a solution of length 3. And then we mark this as the start of the solution. And this is the end. And then we keep moving. And then we compare D and D. This is actually a solution. So I'm going to take it. And I'm going to compare it to the previous solutions that we have already. This is of length 5. It's the biggest so far. And this is the start. And this is the end. So as you can see, this is the first example. It's fairly simple. And then we move the pointers again. And then we check E is different from F. So they are not equal. And we stop and we move to the next I, the next elements. And in this example, as you can see, the center is I, and we centered around one letter. There is the second case where the center is not one letter, but 2 letters. So let's discuss this example. So we're gonna have again, So we're gonna have an array, and instead we're gonna have an I, a pointer here that points, for example, to A, and we're gonna check, we have to check the next elements, I plus 1. If it's equal, then this is the center of the palindromic substring, and it's of length 2. So we're gonna have, in this case, two other pointers, start and end. I'm gonna call them, this is start and this is end, and they're gonna start doing the same thing that we checked before. So for example, if they are B and B, then this is a solution, and this is gonna be of length 4, and this is basically start, and this is end. And then we keep moving the pointers to the left and the right, and we check till the moment they are not equal, and then we stop. So let's code this function. So I'm gonna start by creating certain variables. I'm gonna create n, which is the length of our string, and I'm gonna create max length of the solution that we found so far. I'm gonna initiate it with 1, because at least we are guaranteed that we have at least one letter in the string. So we are guaranteed that the maximum length is at least 1. And I'm gonna have two pointers, the start, which is gonna be pointing at the first element, and also the end, which is also pointing to the first element. And so these variables, they're gonna hold our solution. At the end, all we need to do is to return a substring of s, and the start, from the start pointer till the end pointer plus 1. So fairly simple. And as we said, we're gonna like do a loop. Let's I on our string, I smaller than n, which is the length of the string, I plus plus, and every time we have to basically to check around I. So I'm gonna say check here around I, and I'm gonna code that function in a moment. So let's code that function that checks around an element or whatever. So I'm gonna call it check palindrome. It takes two variables, two in I and j, and the goal is basically to check if the element in I equals to the element in j, and that will be a solution. So first of all, I need to check that I is still within the array, so it's bigger or equal 0, and j is more than n. I'm just making sure that we are within the string and we didn't go overboard. And then every time I have to check if s of I is equal of s on the index j. So if that is the case, then we have a solution. And basically, what do we need to do in that case? We basically have to update. If we found a bigger solutions, we need to update our solution here. So let's check that it's a bigger solution. So j minus I plus 1 bigger than the previous solution, max length. If this is the case, then max length should be updated by j minus I plus 1, and the start is I and the end is j. And then we have to keep checking around, so we're gonna call the function again recursively, palindrome of I minus 1 and j plus 1. And if we didn't find any that s of I equals f of j, so basically that's not a solution. We just like exit the function and we break the recursivity. So that's the only condition we can stop, is when we stop finding a solution or we go over the board of the array. So here, as we said, we go element by element. Every time we have to check around I, so I minus 1 and I plus 1. And this is here is basically treating the case that we said where there is only one element in the center, basically. So I'm just gonna draw it. So when we have I and this, and we check around here and around here. So, but the center is one element. We need also to check when there is two elements that are the center. So I'm gonna check first if I plus 1 is still within the array, and s of I is equal s of I plus 1. So here I made sure that I found a center that contains two elements. And in this case, I need to do the same. But instead of I plus 1, it's going to be an I plus 2. So basically, because we have two elements, as you can see here, this is I plus 1, this is the center, we have to check here and here. And this is I minus 1, and this is I plus 2. I plus 2. But there is one last thing we have to do, is because we are here, the minimum solution is going to be not 1, but it's going to be a 2. So we have to check that as well. So we check if 2 is bigger than max length. If that is the case, then we have to update our solution. So max length is equal to start is I, and end is I plus 1. There you go. So I'm just gonna clean a little bit to make it readable in one page. So as I said, we're gonna do a loop element by element every time we check around the element, but we have to also to consider the case where the center is two elements, so we have to check around them. This is just an edge case to make sure that the minimum solution is not 1. And this is the recursive function that we give it two indexes, I and j. It checks that they are equal. If they are equal, we update the best solution, and then we keep moving by checking around I and j. So I minus 1 and j plus 1. So let's check this solution if it works. And there you go, the test they pass. Let's submit. And it's a really good solution. Yeah, so I hope that the explanation was clear enough for you to understand. This is not an easy question by any means. So if you were struggling with it, that's normal. But I prefer that you, even if you saw the solution, that you will go and you implement it yourself, or you find the solution by yourself and you come and you compare it to this one that I made. And I'm open to discuss if you have a better solution. So yeah, so I hope that you liked the video. Please give a like to the video and also consider subscribing for more videos. And I will see you in the next one.